At this very moment, Guts was 120 kilometers above our heads. In the freezing silence of outer space, something extraordinary is happening. American, Canadian, and Chinese astronauts are living and working together aboard the International Space Station, ISS. They are orbiting Earth at nearly 28,000 kilometers per hour, conducting experiments that will shape the future of science, medicine, and technology. They float in a place where there is almost air, so thin that the molecules are practically non-existent. No ordinary airplane or fighter jet can ever reach them, because there is no atmosphere to create lift. This is humanity's floating laboratory in the sky, the International Space Station. Now let me explain the invisible force that controls everything. When you fire a bullet straight up from a gun, it travels at most 1 to 2 kilometers per second. It goes up for a few moments, but then it slows down, stops, and falls right back to Earth. Why? Because of gravity, the invisible pull of our planet that never stops working. Anything we throw upward, no matter how high, always comes back down. But what if we could fire something much, much faster? What if we gave it a speed of 11 kilometers per second? That magical speed, known as Earth's escape velocity, the object would break free from Earth's gravity forever. It would never fall back. This is the speed needed to leave our planet behind. This is exactly what NASA and SpaceX, every time they send astronauts, food, water, or equipment to the International Space Station. They accelerate their spacecraft to incredible speeds so they can break free of Earth's strong gravitational grip and dock with the ISS. If a spacecraft wants to completely leave our solar system and head into interstellar space, it needs an even higher speed, about 42 kilometers per second. That is the sun's escape velocity at Earth's distance. Anything slower, and it will remain trapped in orbit around our star forever. The same rule applies on a much larger scale. To escape the entire Milky Way galaxy from our position near the Sun, a spacecraft would need roughly 550 kilometers per second. That speed is almost beyond imagination. Even if we somehow achieved in the distant future, we would still be prisoners of even larger cosmic structures. First the local group of galaxies, then the Virgosphere cluster, and beyond. In reality, we are beautifully but firmly trapped by gravity at every level. For the foreseeable future, the farthest we can realistically dream of reaching are the Moon and our neighboring planet Mars. The rest of the universe remains far beyond our current reach. According to NASA scientists, there are approximately 2 trillion galaxies in the observable universe. Think about that number. If a 1-year-old child started counting every single star in the cosmos without eating, drinking, or sleeping for even a second, that child would turn 60 years old before finishing the count, and still wouldn't have counted all the stars. The total number of stars in the universe is greater than all the grains of sand on every beach and desert on Earth combined. Right now, 4 lonely spacecraft are racing toward the edge of our solar system. Voyager 1, Voyager 2, Pioneer 10, and Pioneer 11. Voyager 1 has already traveled so far that the radio signals it sends back to Earth take 22 hours to reach us. Just imagine that distance. These spacecraft are humanity's farthest pioneers, carrying our story into the great unknown. Yet even these brave machines will take tens of thousands of years just to reach the outer boundaries of the Milky Way, and millions of years to truly escape it. With our short human lives of 60 to 80 years, exploring the universe on a grand scale is not just difficult, it is practically impossible. To truly explore the cosmos, we would need lifespans of millions of years. We have not even explored 1% of the universe yet. The observable universe stretches across a staggering 93 billion light years. What we know is nothing compared to what remains unknown. This is the humbling reality of our existence. We are any specks on a pale blue dot, floating in an endless of space and time, bound by gravity, limited by our short lives, yet driven by an unstoppable curiosity to reach for the stars. The universe is vast beyond imagination, mysterious, beautiful, and waiting, and we, small as we are, have only just begun our journey.